Alrighty. So, welcome to Unit 5. This is our first set of notes talking about triangle congruence, and we're digging into more detail than we did in the last unit. This time we're trying to see how little information we need to show that two different triangles are congruent to each other. Now, this set of notes is going to be split up into two parts. The first is going to discuss side, side, side. The second is going to discuss side, angle, side. Eventually, we're going to have practice with both, but because these are a longer set of notes, we're going to split it down the middle. So, let's start by establishing some core ideas. So, given in cat and dog, angle C is congruent to angle D. Angle A is congruent to angle O. Angle T is congruent to angle G. We're also told that CA is congruent to DO, AT is congruent to OG, and CT is congruent to DG. Wow. That's a lot of information. But it's pretty thorough, right? I mean, is there any way you can deny that these two triangles are congruent? Everything matches. Everything's the same. They are congruent. How do we know? Well, because we have all this information. Too much information tells us everything is the same. I mean, we have literally everything telling us that these two triangles are congruent. All the angles line up, all the sides line up. These are definitely congruent triangles. But do we really need all that information? It takes a lot of work, honestly. We shouldn't have to have all three sides and all three angles to determine congruence. I mean, if all corresponding angles and sides of two triangles are congruent, then they have to be congruent. But, however, we don't need all that info to figure that out. We don't need all that information to figure out congruence. We can use like half of that much information, even less maybe. With the right information, we can just use a couple pieces of facts to figure out that two triangles are congruent. So how these notes work is we have all kinds of different congruence rules. This is going to be sets of information we can use to prove that two triangles are congruent. Now, understanding congruence is just one part of this unit. The other part is being able to prove it. We're going to do both in these notes, but we're going to build our way up to that, starting by focusing on one kind of congruence, side, side, side. We're going to represent this with SSS congruence. Basically, if three sides of triangle A, or triangle 1, match three sides of triangle 2, then triangles 1 and 2 are congruent. Simple as that. Oh, I didn't even show that there. If three sides of triangle 1 match three sides of triangle 2, then triangles 1 and 2 are congruent. It's as simple as that. If my sides AC and DF match, my sides AB and DE match, and my sides BC and EF match, all three sides match, then obviously they're congruent. There's no denying it. So we see that they're congruent, but we also have to prove that idea. Moving down to the bottom of our page, we have to make our first proof. Now, what a proof is it's a path of logic that shows how we get from some given information to proving an idea. Ultimately, what we want to do is make a statement that proves that PQR is congruent to STR. So, the last statement we want to make is that triangle PQR is congruent to triangle STR. That is ultimately what we're getting down to. And we want to do that with side-side-side congruence. That will ultimately be our reason, because that's what we're learning right now. So we'll ultimately want to get to side-side-side congruence by using the given information. We're told that PQ is congruent to ST, QR to RT, and we're also told that R is the midpoint of PS. Since it's the midpoint, we also know that PR is congruent to RS. So, we're going to take the facts we're given to ultimately conclude that these two triangles are congruent. We're going to build a logical argument or a proof with these facts. So, it is true that PQ is ST. This is given to us. It's a given, literally. It's also given to us that QR is congruent to RT. This is also given. Finally, it's also given to us that R is the midpoint of PS. This is given. With all this given information, we still need to show that one more side is congruent in order to say that PQR is congruent to STR. We have two sides given already. We need to find the third. Well, the third we figured out ourselves using the midpoint rule. So, because R is the midpoint, we can say that PR, segment PR, is congruent to segment RS. Segment PR is congruent to RS. The reason why is because of the definition of a midpoint. This isn't given to us. We figured it out on our own based on the facts that were already given. We used a step of logic to go from the midpoint to proving this side congruent. Now that we've shown that all three sides are congruent between the two triangles, we can now claim that PQR is congruent to STR. Now that all three sides line up, we can show that PQR is congruent to STR. Okay, let's flip to the back. So the back has a couple other proofs, and they're going to follow a similar process. Ultimately, in question C, we want to prove that JKL is congruent to NKM. Triangle JKL is congruent to triangle NKM. We want to build that up based on a series of given statements, using building up from there to eventually having this finalized proof. So, we're told it's given that JL is congruent to MN. We're also told that K is the midpoint of JN and LM. Well, since we know that, we can go ahead and say that JK is congruent to KN, and LK is congruent to KM. I see side-side-side congruence, don't you? Okay, so we're already given that JL is congruent to MN. This is given to us. Same thing, K is the midpoint of these two. That's given. But now we need to do side-side-side congruence, and to do that we need to make two other statements about the two sides. We can say that JK is congruent to KN. This is because of the definition of a midpoint. We can also say that LK is congruent to KM. This is also the definition of a midpoint. Now that we have all three sets of sides shown congruence, we can finally prove that JKL is congruent to NKM because of side-side-side congruence. Once we build up that all three sides are congruent, we can claim that they use SSS and show that triangle JKL is congruent to triangle NKM. Okay, we have one more proof. We're given that AC is congruent to AD. We're also told that CB is congruent to BD. But what about the last side? Both triangles share AB. What we can say is that AB is congruent to itself. And that's what we're going to do in this proof below. AC is congruent to AD. This is given. And CB is congruent to BD. This is also given. Lastly, we need one more side to show side-side-side congruence. So we're going to say that AB is congruent to AB. We're using a property for this called the reflexive property. It's reflexive because it's reflecting on itself. It's the same thing reflected. Now that we've shown that all three sides here are congruent, we can now make a statement about triangles ABC and ABD. Triangle ABC is congruent to triangle ABD. All three sides are congruent to each other, so we use side-side-side congruence. Okay, so that was our first style of congruence. It's all side-side-side. We can build proofs by making claims based on given information and ultimately conclude that they're congruent using side-side-side. In the next video, we're going to move on to side-angle-side and show how it's very similar and in many ways also very different. So, thank you very much. I'll see you in the next video.